Welcome to my channel. In this video, we want to look at derivatives of function, but this time around, we are looking at product rule. Now, so the question is, how do we make use of this product rule? So we say that let y be equals to uv. Uv means u times v. So where both u and v are functions of x, meaning that u is equals to function of x and v is equals to another function of x. We have dealt with what functions mean in our previous video. So let's say, for instance, now maybe you will have y equals to exponential x sine x. So these are two different functions. So here now I can say that u is equals to exponential x and v is equals to sine x. So as you can see now, if you bring uv together, just like we have it as product here, we're going to have exponential x sine x. So this is a typical example that we make use of product rule. So now if y is equals to uv, where both u and v are functions of x, we have that the y dx is equals to u dv dx plus v du dx. So this is the rule for product. We have that the y dx is equals to u dv dx plus v du dx. So meaning that the u and v are already known from the question given. Like in this case now, we have here y equals to exponential x sine x. So I can, as we have said, we said here that let u be equals to exponential x and v be equals to sine x. So that means if you're going to find the y dx for this one now, what you just need to find next is to find the value for the v dx, which means find the derivative of v with respect to x, and then we have the u dx, which means finding the derivative of u with respect to x. So in that sense now, if you have to look at what we are given here now, you agree with me that the u dx is equals to exponential x, reason being that that is still the meaning of that's just the derivative of exponential x. Then at the same time, the v dx here is going to be cos x, because the derivative of sine x is equals to cos x. So now in this place now, therefore we can say that the y dx is equals to, since we know the value of u and v to be exponential x sine x, and now we have found the derivative respectively, we have found the u dx, we have found the v dx, so we just insert all that we have into this equation now. So u is exponential x. Now the v dx, we got the v dx as cos x, so that become cos x plus v is equal to sine x, so we have here sine x. Then the u dx, we have the u dx to be equals to exponential x, so we have exponential x. So since exponential x is common, we have exponential x into bracket cos x plus sine x. So this one here now represents the derivative of y, where y is equal to exponential x sine x. So this is just a typical example of how to make use of the product rule. All right. So now, yeah, so in this example 2, we have to find the y dx if y equals to x squared ln x. So as you can see, this also looks like product of two functions, where we can say now that let u be equals to x squared, which is a polynomial function, and v be equals to ln x, which is a logarithmic function. So the next thing we need to find out is that, since we know that this is a product rule, that the derivative of product rule is given as u dv dx plus v du dx. So what it means now that is that since we have the v dx and the u dx, we have to find the derivative of these two respectively. So the u dx now is equals to 2x, that's the derivative of this x squared. Then the v dx is equals to 1 over x, that's the derivative of ln x. And I told you that ln x is the same thing as log x base e. So now, since we have found the u dx and the v dx, so we can go now to use this particular rule or this equation in order to get the derivative of this y equals to x squared ln x. So the y dx therefore is equals to u is x squared, so we have x squared dot dv dx now is 1 over x, so we have here 1 over x plus v is equals to ln x, so we have ln x dot, then du dx is equals to 2x, so we have here 2x. So now this will be equals to, so you can see x, this is s squared over x, that's going to give us x, because x will cancel one x, here we have x, then plus this is going to give us 2x ln x. So one thing we have to be careful of here is that ln x dot 2x, meaning ln x times 2x, is not equal to ln 2x squared. No. Reason being that this is a polynomial function while this one is a logarithmic function. So this and this are not multiply each other. So it is written as 2x ln x. So at the same time, x is common to both of them. X is common here. So you can see x into 1 plus 2 ln x. So please take note, it is not this x here that we pick, but rather this x here. Reason being that logarithmic functions, as we have seen them, logarithmic functions are defined as, we have them as log n base a. This is the way logarithmic functions are defined. So when you are factorizing, you can't take this away and say maybe you are bringing out n, maybe n is common, stuff like that. Maybe you have another one now, maybe n, maybe log m base a. I'm not looking at n and n. Then you bring out n and say n, maybe log 1 base a plus log m base a. This is incorrect. This is incorrect. Reason being that this is the number whose logarithm you want to find. Why this one mean this number multiplying the logarithm of this particular n. So there are two different things. This is the way logarithmic functions are explained and are expressed, and that is why this 2x can multiply this x, and at the same time when factoring out x, you don't make use of this one. So this is the answer for the derivative of y equals to x squared ln x. So we're going to consider some other example to make it clearer. Thank you.